Refinery Optimizer, que va a ser en inglés, y las preguntas las pueden hacer tanto en inglés o en castellano, y yo voy a intentar traducirlas.
Hello and good afternoon to everyone. My name is Gipson. I am with Teradata. I'm a senior industry consultant there. I'd like to talk to you a little bit today about the Refinery Optimizer and what it can do with end product blending. This presentation is divided into two parts, one around data management and then one divided into talking about data analysis and analytics that can be done in the gasoline blending, and then we'll go into a short demo. So let's go ahead and get started. A lot to cover. So the refinery challenges we see with our customers, there's really no end-to-end view. There's no real one version of the truth. There's always fighting of where the data came from, what source did you use, what timestamp did you get that information from, how is it being put together. You'll see there are two that are really highlighted there, the landscape and data and decisions. We believe that if you get your data correct, it will fix a lot of problems that you have. Integrating that data and putting it on in a business hub, creating one version of the truth creates business transparency, which you can use to make quicker decisions. This information is done in near real time. And then that allows you to do real analytics and data science using that data to actually get real answers and compare apples to apples. Anytime you do any type of analytics or data science, garbage in is garbage out. So having that one version of the truth is really important.
Johnny?
Yes.
You have your camera off.
Oh, I will fix that.
Thanks.
The success of this happening is usually a function of simplicity. Usually what we have is a lot of data marts, a lot of applications. We're pulling information from different sources. Usually we're combining this information with another data source or another data mart, putting that together and just to put in an Excel spreadsheet and to give it to someone else so they can do something else with. I'm pretty sure everyone is used to this. What we want to do is be able to create a business hub where everything talks to one another. Everything's on an integrated data model. Your material reference codes, your product codes, everything's there that SAP easily talks to other systems. You have all your OT systems, your IT systems, and your ERP systems coming all together to create that rich data information that you need. So just wanted to show you some of the use cases that have been put into production and the value that you see here. When you have that integrated data, that rich data, the biggest thing that happens is that no longer this is siloed data that one person is using. What you will find is that other I would say functions in your organization needs this data just as badly as you do. So let's take inventory, for example. So a person that's in the field needs inventory data. They need to know what tanks are empty, what tanks to go into, but also your schedulers, your trade department. You want to be able to make better trades. You want to be able to make better deals. Your treasury, you want to be able to do better hedging. Your supply function, your finance function, you want to know that working capital, that inventory information goes into making those working capital decisions. So having a more up-to-date inventory number, saying happening every 15 minutes versus a midnight snapshot that you've just worked up and then you guys are working that throughout the day, having that information more readily available causes better decisions and cause you to just take advantage of every opportunity that you have. So the one thing that we understand that applications do certain things and you need those applications. But there are some things that we've created point solutions for that only helps that one analyst or that one persona. What we want to do is try to get this information to the hands to everyone that needs that information. So like the example today, we were just talking about inventory. That inventory information should be shared throughout not just from the refinery, but all the way down that supply chain. So everyone knows what is happening at the refinery, everyone knows what's happening at the terminal, and then people can make decisions to get the right things in the right places. So how does this happen? So basically, this business analytic hub, we're not replacing any sources, but what we have done, we're connecting those sources and putting it on an integrated data model. And then we're using your business rules, we're using business logic, and then we're working with IT and the business to get the things that where we consider, what's considered dirty data, what's considered bad data, and what are the calculations that you have to do? Do you do any quality things that you need to do with the data? So we're trying to put that all in one place, curate that data, create one version of the truth, and then we break that out into subject areas, and then we put that to the power user. And what we have done is we've created basically screens and applications from the field all the way to the C-suite. So people are looking at the same information, looking at the same timestamp, but you want to look at it different ways. What a senior manager wants to look at is different than what a person sitting at the crude pipe still wants to look at. So this is just our integrated data model, and this is kind of how we kind of have it set up. And these are the materials or subject areas that you see. We usually like to start off with materials and sensors and get the inventory and pricing. But where you start is more of a function of what your biggest pain point is. We want to solve that biggest pain point. We have different load types. The dashboards don't necessarily have to be in Tableau. You can do Power BI, Spotfire, but we want to be able to offer you something that you can use that as a self-starter to get moving very quickly. In our experience, these are the systems and applications that we have connected to. As you can see here, we get these to talk together and give you that rich source of data. Now we just wanted to jump into blending. The Refinery Optimizer has been very helpful in helping in the blending area. The one thing that we have done in the past that every company has done, for us to understand blending, we've actually just reduced it to a linear equation, AX equals B. Basically, that's all our linear programs. That's all we've really done. We have done some things with some other machine learning things, but usually it kind of boils down to this. We want our LP, or we've used Asyntech and BO to actually make biases to optimize that equation. But product giveaway is a huge value, 100 million per year in lost revenue. So why are we losing so much money? Well, blending is not really linear. It's very nonlinear. Those blend components that are blending together, there are blend interactions that happen that are not linear. And then we go to our blend workflow process. And as you can see, when you're planning your tank qualities, from your blend controls to the lab to the blend reports, all that is data rich, and there's always an opportunity for something to happen if you do not have your data curated or coming in correctly. So all the yellow boxes that you see here with the red, if you cannot answer these questions, you are leaving money on the ground. That is real dollars that you cannot that you cannot get back. And so this is volume that's being wasted. And so being able to answer these questions very quickly and more robustly will actually stop your gross margin erosion in your blending. And then also this, I've seen this with a lot with our customers, and I used to do this when I was a blend engineer. We throw everything in Excel, and I put my historian data in there. I use my yield management. I throw that in there, my market pricing, my lens, and at the end of the day, we're all human, and you can actually end up with a 30% error rate once you do all of that. And so putting everything in your data warehouse or in a data system or anywhere you want to put it. Removing the human keyboard element will save you a lot of time and a lot of money. Because usually what happens if you find an error, you have to correct that error before you can start your next blend or before you can start the next batch. So in the last 20 years, how we've dealt with this product giveaway, I said it's a $100 million problem. And so we've done different things. We've started to, usually we define those giveaway conditions. We've done feature association. When this product's off, this means this is going to happen. We've done classification. When we're off on sulfur or we're off on RVP, that means we've put this too much of this component into the thing. So we've actually kind of reduced the problem, but it's a look back to actually make the next blend better. But there is still a large opportunity. We've only reduced the problem by 30%. And things that we use polynomial functions, random forests, but there are still ways to combat this problem that is even better, which is neural networks. Neural networks has been around forever. The only problem with neural networks is that we haven't had the computing power until now. We have the compute power. Usually what happened back in the 80s or early 90s to train a neural network would take months. Now it can take an hour or a day. You know what your inputs are. You already know what the outputs have to be. So let the computer do the work for you and look at those blend interactions. And that's what makes this so powerful. The neural network is not these interactions that are occurring between the components, but also the neural network is also able to provide you a way to propagate the arrow back to actually figure out what the correct input is. And what I would suggest to people is that you already have recipes. You don't have to start from a blank slate. Put those recipes in. You already know what the output is. See how you can tweak those recipes and move things around to get a better recipe. Don't start from scratch. You already use the recipes that you have. So can neural networks start with giveaway? Yes, it's been proven many times. There's plenty of papers out there. Some of the practices that are used is from Schulholm and Lundestad, two of our German friends that put this together in the 90s, and they've predicted it within 0.1 of Mon and Ron, and they used that to explain that with great accuracy. There are more papers out there actually pushing this even more into the emission type space. And so why is this not being used? Well, the problem is, like I said before, it's the compute power, and we have that now. The other thing is that we need you need the tools. To create a neural network is not it's not an Excel type thing. You have to use TensorFlow. You have to have the data. You have to have your data curated. Sometimes it's an investment of just increasing sampling or increasing the labs, and it's also a cultural change. How many times have you seen an operator just use still data just to get the blend started? I'm use this old lab that I have for this old component, and I think it's good. But once you get the new lab back, you realize it's different. Those distillations are different. So it's about changing the culture as well. We're not going to use still data anymore. We're going to use more data. So here are some references that you can look at to get more details around what those equations are that they were used, and you can set those up in TensorFlow or PyTorch or any open source tool that you want. But again, it all starts with the data. It has to be garbage in equals garbage out. Clean data sets will get you a very nice clean answer. And right now, I just want to go to a demo that we have here. I'll enlarge this. So, and it is thinking here. Usually what we've done is, I will tell you, in corporations, usually the way that we kind of hide our blending giveaway is that we usually do an aggregate of everything. Usually we say, oh, we have 0 giveaway. Well, that's because we've basically taken all our refineries or all our units together and averaged it all together. It's only when we break it out and start looking deeper into the details that we start to see, hey, we are really losing some money. We have this system, this El Paso refinery that's blending over. We have this Pascagoula refinery that's actually blending under, and sometimes you have to have a pure cultural change of what does blending under mean. I've had people say, well, we blend under because we know that this system blends over and it averages out. Well, actually, you're making off-spec product, and that causes your supply chain and your traders having to buy things from the outside to actually bring that gasoline up to that octane. Like they have to buy extra component to splash into the terminal tank to actually bring it up so they can ship it out. And so that's just extra money. But since you're in a siloed organization, you think you're fine, and it's just because that cost is being put somewhere else and not on your books that you don't think that you're doing okay. So then we also want to also show like the operator. So here's what we predicted what the recipe was, and this is the actual that happened. Are they blending closer, or are they not really paying attention to the components that are being blended in? And you can drill down to see what the components are being used and see the other components. And you can quickly drill down to different sites and look at different things. Change the site here and see what's going on. You can change the month. You can look at Salt Lake. So you can do different looks and see what's really going on in your system. And this is a corporate view. So what we would have for our operator would be totally different. It would be based on that batch, what is going on. And so instead of showing like this TensorFlow workbook or anything, all that is happening in the background. We don't want to show that to our operator. I don't want to show that to you because that's not what the operator really needs. What happens is that all those workbooks run within your data warehouse or your cloud, and it spits out a recipe, and it's up to the operator to get to that recipe. And then we can see if you're really off, we can go back and it will trigger for that model to be reevaluated, to be retrained, and to see if we can get closer each time. And so, but then again, it starts with the data. And then this is not just for, gasoline blending, but we can also do this as well for our diesel. We know that a lot of things are diesel properties. Those are usually cold flow properties that come from crude, and we can't really change that unless we change our crude slate. But it's good to have this information so when you have that discussion with a trader, you can say, hey, this crude that we're usually running, it really doesn't work for our cetane. It has a very low cetane. Or this flash here, we're always kind of bumping against flash, and that's because we don't have the steam stripper on. And then we can also look at the steam. Okay, then we can also look at the sulfur giveaway here. And this is more around catalyst. Are we really overrunning our catalyst reactor? And then we can just do a quick hover over and see how each unit's working and which one is doing more catalyst or not. This is all I kind of wanted to show, and I will open it up for questions.
Okay, so I'm not seeing the questions. I don't know if there are some other questions that have been sent. I have one question for you, Johnny. My question would be the following. 1 second. Considering business questions could be very diverse, not only of one type, how do you integrate the data model? How do you integrate different levels of granularity, focus on different things, on different data types? Do you have a model that integrates everything at the bottom?
Yeah, so what we like to do is start at the most granular piece of data. What we try to understand is the business problem and understand the business impact, because going to a very low granularity may not have a big impact for the way the business works. So understanding that, and then we can start at that most granular level. So like say for instance SAP. aggregates everything. We can get at the granular level. So the question is, how far do you want to go down? Do you want to go down to an equipment, pieces of equipment, or do you just want to stop at a certain subcategory? Like, do we just want to say is exchangers? We don't want to go down to individual pieces of equipment. So that is a discussion that we have with the business of how they want to move forward with their data practices.
Okay, another question from Gerardo Jardes is, how long does it take to implement this kind of solutions?
So for us, also it depends on again on the business problem and the complexity. But usually we have starters that we have that in 3 to 5 months time you can be up and running on a 1 or 2 use cases, and those use cases contain visualizations from all the way for affecting the field, and putting it into the field all the way to the C-suite. So usually in 3 months time we can usually roll out 1 or 2 big use cases, and then what we also try to do is teach your IT and your business organization that how we're doing it. So you tend to roll us off, and you start to take that up on your own to move further along the roadmap.
Okay, is there any other questions? And if not, thank you, Johnny, for your presentation. So, así con esta última presentación hemos llegado al final de las presentaciones del día.